So welcome back students. So now today we are going to see few examples based on the Euclid division lemma of expressing the two numbers in a relationship. In the previous video we have already studied about how to express the two numbers in the relationship using the Euclid division lemma. So today we will see with few examples so that this concept is clear in your mind, and application of these Euclid division lemma is there in the next topic, so it would be easy for you to understand the next topic. So let's start the video. So the first example is 127 and 5. So before starting with this, let's try to revise Euclid division lemma. Quick revise. Euclid division lemma was A is equals to BQ plus R. In this, A and B are the two positive integers which we take, and Q is the quotient where R is the remainder. So now in this example, the two integers are already given, 127 and 5. So first of all, we have to select the value of A and B. So in the statement of the Euclid division lemma, we have already studied the integer which is greater is taken as A and the smaller integer is taken as B. So in this question, 127 is our A and this 5 is our B. Now once we get the value of A and B, now we have to divide the bigger integer with the smaller integer. So now let's divide 127 by 5. Let's perform the division. So in this division we can see 125 and divided 127 is divided by 5. So 5 2s are 10. The remainder is 2. Then this 7 is carry forwarded. 5 5s are 25. Remainder is 2. Now further division we cannot do because now the remainder is less than the divisor. In the previous video I have already explained that we never take the division into decimals. So we have to stop the division here. So now from this division we get the value of Q, and here we got the value of R. So now I know A, B, Q and R. So by using the Euclid division lemma, A is equals to BQ plus R. So now value of A is 127 is equals to value of B is 5 into value of Q is 25 and the value of R is 2. So this is the relationship between 127 and 5 which is expressed with the help of Euclid division lemma. So now in this second example we can see the first integer is given 40 and second integer is given 161. So now don't get confused that first integer is always A. No, the condition of selecting A, always remember the bigger integer is always taken as A. Whatever may be the place of the integer. In this question the first value was bigger, that's why we have taken it as A. In second example we can see the second value is greater. So here the value of A will be 161 and the value of B will be 40. So now again we will perform the division. Now we will divide A with the B. So now 161 divided by 40. So let's divide 161 by 40. So we know 40 4s are 160. Subtract, remainder is 1. Now in the first step itself we got the value of remainder less than the divisor. So here itself we have to stop the division. So from this division we got the value of Q and we got the value of R. So again by Euclid division lemma, A is equals to BQ plus R. So value of A is 161 is equals to value of B is 40. The value of Q is 4 and the value of R is 1. So this is the relationship between 161 and 40. Now moving ahead with the third example. So here again first integer is 20 and the second integer is 1200. So now what will be the value of A? So value of A will be 1200 because the greater value is always A and the smaller value is always B. So again here also we will perform the division. 1200 divided by 20, 26 are 120, remain this is 0, 0, 0, then this 0 we will carry forward, 20, zeros are 0, the remainder is 0. So now here we can see that in this case the remainder, the value of remainder we got as a 0. This we have already discussed in the previous video that remainder value either it can be 0 or more than 0, but it is always less than b. That means the value of remainder can be 0 and more than 0. In this case, we saw the remainder is 2. Here in this case, we saw the remainder is 1. In this case, we got remainder value as 0. The value of remainder can never be less than 0. So again, we will express with the help of Euclid division lemma. A is equals to b cube plus r. So value of a in this question, it is 1200 is equals to 20 into 60 plus 0. So this is the relationship between 1200 and 20 with the help of Euclid division lemma. Now coming to the last example of Euclid division lemma. Now many of you might be thinking, sir, why you are taking so many of examples? So this concept is very important because in the next topic we are going to study how to find out the HCF. That means in the next video we are going to study what are the real life application of Euclid division lemma. So there are two main applications of Euclid division lemma. The first one is to find out the HCF, that is the highest common factor of any two numbers or any three numbers using the Euclid division lemma. And the second application is how to represent a number into its general form. That means we are going to see the various general form of the numbers which have been derived with the help of Euclid division lemma. So these are the two major examples, or these are the two major applications of Euclid division lemma. So that's the reason this concept should be very much clear in your mind, and that's the reason I am taking so many of examples. So today's our last example is 2478 and the second integer is 15. So now here again two values we have. So the value of a out of these two integers 2478, it is but obvious it is greater, so we will take it as a, and 15 is the smaller value, we will take it as a b. Now let's divide a by b. That means we have to divide 2478 by 15. Now let's count the table of 15. So 15 ones are 15. Now 24 minus 15, that is 14 minus 5. 14 minus 5 is 9. It is 0. Now this 7 we will carry forward. Now count the table of 15. Now 15 6a. 15 6a is 90. So it is 90. Then again subtraction 70. Then this 8 we will get it down. Now 15. Now when we count the table, 15 5a 75. Now remainder is 3. Now again we reach the position where the remainder is less than our divisor. So now in this case our remainder is less than divisor, so we will stop the division. So this 165 will become q and this 3 will become r. So again by Euclid division lemma, that is a is equals to bq plus r. So value of a is 2478 is equals to 15 into 165 plus 3. So this is the relationship between 2478 and the 15, which is expressed with the help of Euclid division lemma. So I hope I was able to clear all your doubts regarding the Euclid division lemma, how to express any two integers. Now you will be able to express any two integers in the form a is equals to bq plus r. Still, if you have any doubt, please mention your doubts in the comment section so that in the upcoming videos I can solve your doubts. Till then, keep working hard and make your parents proud. See you in the next video.